This is Calculus 2 class, so we're gonna study ratio test. Ratio test is most powerful test to check if a series convergent, divergent. So guys, pay attention to this test. Which series you're gonna use for ratio test? Which series you cannot use it for ratio test? Before I introduce ratio test, I want to know which infinity series might use for ratio test. So ratio tests have the infinity series convergent to divergent when they have this term, when they have factorial, factorial, or exponential expression. I'm going to give example later, guys. Keep in mind, ratio test is very effective for the series with factorial exponential expression. So that's you're going to using ratio test. So what is a ratio test? Ratio test is very simple. You're going to check it out. What is a ratio test is we're going to find the ratio. When you see infinity series, it looks like summation an. We want to figure it out. This infinity series convergent divergent. Ratio test say we're gonna find an right there, an plus 1. You're gonna find the general term and next term. Find the ratio. Very carefully here, absolute value. So sometimes an might be alternating series. So make sure you find the general term an plus 1 divided by an absolute value, take a limit. We want to find the limit L. L gonna be between less than 1, less than 1. This one is here. L gonna be always positive, less than 1. Then series absolutely convergence. Absolute convergence meaning is this series is convergent. This ratio, limit of ratio gonna be greater than 1 or that's not going to, that doesn't have a limit, going to infinity. That's going to be series, going to be divergent. Last one is important. Limit of this ratio is 1. We have tried different tests, like different tests going to be comparison test, integral test, or what else? So what else we have? Alternating series test. So making sure you're gonna find the general term. First, you have to find the general term an. You find the ratio is an plus 1 over an. Take absolute value. Then you're gonna take a limit and find this limit. Then decide this limit is greater than 1, less than 1. This one is 1. Depends on this limit, you decide this series gonna be convergent, divergent, or you cannot determine. So that's the ratio test. So I emphasize one more time, you're gonna using ratio test is a factorial form expression, exponential expression form. So I'm gonna give example for the P series why you should not use P series to determine if a series is gonna be convergent to divergent. Look at this P series. One is the first one is look at this one, guys. Look at this one. This one is you're gonna know this is a P series. First one, P gonna be 2 converge. This one is a harmonic series. This one is p value is 1. That's the diverge. What happened when you're using ratio test? First one is, let's start with the first one, summation 1 over n squared. What is an? Here is 1 over n squared, right? We want to find an plus 1. That's going to be very careful. Here is n, here is n squared, n plus 1 squared, right? Then we want to find the limit L, limit and approach to infinity absolute value, an plus 1 is top, 1 over n plus 1 square over 1 over n square. So you don't need absolute value because this sequence is positive. Drop the absolute value, simplify this fractional fraction, that's n square, n plus 1 square. You want to find the limit, right? Limit. So limit n approaches to infinity. Here, both sides n square, or you're going to expand the bottom, n square plus 2n plus 1. You can use L'Hopital rule, 2n plus 2. Using L'Hopital rule one more time, 2 and 2, that's 1. So this L value is 1, but we already know this series converges. How about this harmonic series? Let's go harmonic series here. So an is 1 over n, an plus 1 is 1 over n plus 1. So limit and approach to infinity, we want to find L, limit of ratio. Here is an plus 1, 1 over n plus 1, 1 over n. Drop the absolute value because that's the positive. N over n plus 1, using L'Hopital rule. 1 and 1, that's the 1. What happened, guys? Look at the clearly see it. P equal to is converse. Right here, L is gonna be 1. P equal 1 harmonic series, L is 1. The other series diverge. So we cannot decide by the ratio test when the limit of ratio is 1. In that case, you are not use ratio test. If L is limit an plus 1 over an is 1. Okay, so P series form, you should not using ratio test. Let's practice ratio test for this kind of a series. Guys, look at this one. A and B, guys. Very carefully see it, guys. Look at this one. First one. Look at the first one. These series have factorial and exponential form. This is factorial form in the bottom. On the top is gonna be exponential form. This case, you should using ratio test. Okay, let's use ratio test to determine if this series is going to be convergent divergent. So first one is you have to find what is an. An is 2n and factorial. So what is an plus 1? N gonna be replaced with n plus 1, 2n plus 1, n gonna be n plus 1 factorial. Let's find limit of this ratio. Before we evaluate limit of ratio, I'm gonna briefly show simple tips to simplify this ratio. So we wanna simplify ratio looks like an plus 1 over an. So an plus 1 is 2n plus 1 over n plus 1 factorial divided by 2n over n factorial. Fraction of fraction, right, guys? So this one is divided to n plus 1 over n plus 1 factorial. Here is denominator. You should flip it because that's going to times it. That's n factorial to n. Okay, so from now on, when you're talking about limit, here is right there, guys. L gonna be limit n approach to infinity. An plus, this term is an plus 1. This one is a flipped an. So here is an is 2n plus 1 over n plus 1 factorial times, look at this one. This one is right there. This form is gonna be 1 over an. So 1 over n is a prefix, and factorial is 2n. That's you write it, then you're going to find the limit very quickly, guys. Look at this first. Let's see, this one is, I'm going to need space right there, guys. So now simplify this one. Here is limit 2n plus 1 over 2n. I'm going to move the other side times n factorial over n plus 1. I'm going to switch the denominator. Now simplify 2n plus 2n, 2n plus 2n plus 1, 2n times 2. So I can cancel 2n, 2n. Okay, so how about this one? N factorial divided by n plus 1. This one is meaning is, guys, each term 1 times 2 times 3 times until n. 1 times 2 times 3 times n plus 1. What is before the n plus 1? That's the n. So what is cancel out here, guys? Cancel out everything. Remainder is here. So now we simplify this one. Limit and approach to infinity 2 over n plus 1. Guys, make sense? Then what is this limit gonna be? 0 and approach to infinity. So your conclusion is this series gonna be converged. Why this is L is since L is less than 1. That's how to do ratio. There's another way, this sequence decreasing exponentially as an approach to infinity. That's why this series is going to be converged. Let's do the second one, guys. B part gonna be, what is have first? You have to know what is an. 2n over n. So an plus 1 gonna be 2n plus 1 over n plus 1, right? So we want to find the limit L, limit n approach to infinity, an plus 1 to n plus 1 over n plus 1 times 1 over an. That's going to be flip an, n over 2n. So limit n approach to infinity to n plus 1 to n over n plus 1. So you see this one is cancel out. What you left? 2. So I find the limit 2n, n plus 1, L'Hopital rule, that's going to be limit 2, 1, that's going to be 2. So since L is greater than 1, this series 2n over n diverges. Okay, do you feel much easier than previous test we studied? So keep in mind that you're going to find an plus 1, find the ratio, take the limit, check where limit go. L going to be less than 1, conversion, L is greater than 1, divergent, L is 1, we cannot decide. Let's practice more, guys. So before we start ratio test, let's check it out. This one is power, right? This one is exponential form. That's why we can use ratio test. So see, first you have find an. N squared 2n plus 1 over 3n. What is an plus 1? Replace n with n plus 1. N plus 1 square, 2n plus 1 plus 1, 3n plus 1. N plus 1 square, 2n plus 2 over 3n plus 1. Guys, make sense? So what is the ratio test? L gonna be limit n approach to infinity an plus 1 times 1 over an. I'm not going to put the absolute value because this sequence is positive. limit n approach to infinity n plus 1 square 2n plus 2 over 3n plus 1 times an is flip it 3n n square 2n plus 1. Guys, make sense? Then what you have to do, simplify this one is gonna be another work. So you have limit n approach to infinity. I switch it. That's here. You don't have to switch if you can simplify quickly. This one. First one, that's gonna be 3 because this is 3n times 3. So that's gonna be cancel out, right? This one is cancel out. Okay, next one. Here is gonna be n plus 1 square, n square. So I'm gonna write it here. N plus 1 square, n square. Another one you have right here, 2n plus 2, 2n plus 1. So how can simplify 2n plus 2 over 2n plus 1? This number n plus 2 is increasing by 1. This one is gonna be 2. Guys, okay? So you have here is a 2. That's you simplify this one, guys, okay? Everyone, makes sense? Now, so I need a space here. How can find this limit, guys? So this limit n approach to infinity. 2 over 3 is number. You don't worry about it. How about this limit? This limit, guys. How about this limit? Okay, this one is gonna be n squared plus 2n plus 1 over n squared, right? So we're gonna using L'Hopital rule here, 2n plus 2, 2n. So you can use L'Hopital rule one more time. So this one is 2 over 3 limit n approach to infinity 2n. Oh no, the L'Hopital rule gonna be 2 over 2. This limit gonna be 1. That's the 2 over 3. What are you gonna say? This one is L is less than 1. The conclusion is this theory is gonna be converged. Guys, make sense? Let's do the D, guys. So we're gonna using ratio test. Why this is exponential? 3 to the n. That's gonna be power. That's we're using ratio test. First step is you have to find the general term an. N cube over 3n. This is D. What is an plus 1 gonna be? N plus 1 cube, 3n plus 1. So we have to find the ratio and take a limit, right, guys? So L gonna be limit an. That's gonna be n plus 1 cube, 3n plus 1 times 1 over n, 3n over n cube, right? Then let's see. First, this one. This one is 3n times 3. So let's cancel out 3n, 3n. So you have limit. Here is 1 over 3. Now, second part, n cube, n plus 1 cube. That's gonna be n plus 1 cube, n cube. So we want to find the second part. Constant is, we don't worry about it. 3, 1 over 3 limit and approach to infinity. Cube, same power. So I'm going to put this one big parentheses n plus 1 n cube. This is much easier to find the limit compared to expanding that n plus 1 cube. So this one we learn from the limit of sequence. Plug in the limit inside cube. what is this inside the limit? Everyone, this one is 1, right? This one is a limit 1 over 1, that's 1. So you have 1 over 3, 1 cube, that's 1 over 3. Now, what is conclusion? So L is gonna be less than 1. So we say this 3 is gonna be converge. You guys understand how to find the limit of a ratio? Then how you simplify? Just list my tips. Much easier way to simplify ratio of sequence, guys, okay? Now let's have another example. Previous examples in the series, each term is positive, so we don't worry about absolute conversion, conditional conversion. But what's the really good thing about ratio test? We can use ratio test for alternating series too. So when you use ratio test, you guys make sure put the absolute value for the ratio test. Look at this example, guys, right here. So this one is alternating series here, alternating series. Because this one also alternating series because negative 3n, negative 1n, 3n. You're going to separate. So this term represents alternating series. But you have to feel like I'm going to use alternating series test for this. No. So this time it's the same rule apply for the series. Look at this bottom. They have exponential form here. Factorial is right there. You should use a ratio test even you have alternating series. So ratio test is a popular test. You can use any series except P series and harmonic series. That's much easier to figure it out. This series is going to be convergent to divergent. So even alternating series, we can use a ratio test with exponential form and factorial. So let's practice this one first. So an gonna be here. We're gonna start the a. So this one first. So an, of course, this one is negative 1n minus 1 n cubed over n 3n. An plus 1 gonna be negative 1 n plus 1 minus 1 n plus 1 cube 3n plus 1. So this one is a simplified negative 1n n plus 1 cube 3n plus 1. So we want to find L limit. Don't forget the absolute value because they have alternating sign is right there. So what are you gonna do? An plus 1 is negative 1n, n plus 1 cube over 3n plus 1. I need more space. Times 1 over n, 3n, negative 1n minus 1, n cube. But good news about absolute value is you don't worry about negative inside the absolute value. So you're gonna drop the negative no matter what this one. So this one is make a positive. Everything else is a positive. So you're gonna find the limit here, n plus 1 cube over 3n plus 1 times 3n over n cube. We already did this previous slides. Guys, look at this one. First, this one cancel out. 3 is left. So we have limit and approach to infinity. 1 over 3 n plus 1 cube over n cube. This limit gonna be 1. So we have this one is 1 over 3. L is less than 1. Our conclusion is, guys, our conclusion is this series converges absolutely. What is mean by absolutely converse is meaning is two things right here. You just remember previous session. Meaning is this one is converse and you drop the sign. So absolute converse meaning is this alternating series converse and this drop the sign. This series is going to be converse. Let's have another example. Let's do the second. We talk about why we should use ratio test, the B part, but here's the factorial that we're going to use in ratio test. As you see, this is alternating series. So let's figure it out. This series is going to be converse or not. So B part, you have find an negative 3n over n factorial. So this one is an plus 1 negative 3 n plus 1 over n plus 1 factorial. So we want to find the L value, limit, n approach to infinity, an plus 1, negative 3, n plus 1, n plus 1 factorial, times 1 of n factorial over negative 3n. Okay? Let's figure it out. This one, simplify. Here is n plus 1, here is n. That's going to be negative 3n times negative 3. So you have negative 3 right here. Negative 3, n factorial, n plus 1 factorial. We talk about it, right? N factorial, 1 times 2 times all the way n plus 1 factorial, 1 times 2 times 3 times n plus 1. So what is cancel out? This whole thing is cancel out. You have limit and approach to infinity, negative 3 over n plus 1. This is absolute value, so negative 3 gonna be 3. This limit going to 0. So this is, of course, less than 1. Our conclusion is summation negative 3 to n over n factorial is converse absolutely. What is mean by that? Summation negative 3n over n factorial converse. Summation 3n over n factorial converse. That's the meaning of absolute value. Alternating series converse. Drop all the sign. Another positive series is gonna be converse. Guys, understand ratio test works? Let's do another example for ratio test. This one is gonna be definitely alternating series. But why alternating series not work for these two series? So definitely this one is alternating series. How do you know? This part. Same is here, this one. That's alternating series. But both them do not work for a ratio test because this sign is dropped, looks like a series. This one is gonna be, looks like summation 1 over square root of n. That's gonna be P series. So that's definitely we talk about L gonna be 1. So it's not working. You practice the ratio test with this, we're gonna find the L is 1. So it's not working for ratio test. How about this one? This one is, we're gonna try to this one. Let's try the D. So an gonna be negative 1 and n 2n plus 1, an plus 1, negative 1n plus 1, n plus 1, 2n plus 1 plus 1. You replace n with n plus 1, negative 1n plus 1 times n plus 1 over distribute 2n plus 2, so 2n plus 3. Let's find the L value, limit and approach the infinity. An plus 1, negative 1n plus 1 times n plus 1 over 2n plus 3 times 1 over n, negative 1 and n bottom 2n plus 1. As we did the previous slides, this drop because alternating series, they have sign is alternating, but we take absolute value, so you're going to put this one this way. So n plus 1, 2n plus 1, 2n plus 3, n. You want to find this limit? Let's expand it. Here is 2n squared plus 3n plus 1. Bottom is 2n squared plus 3n. So you're going to use L'Hopital, right? 4n plus 3, 4n plus 3. That's limit is 1. So this limit of ratio is 1. So we cannot decide that this one is going to be converged divergent. What do you have to do this one to figure it out? We have to alternating series test. Okay, so alternating series test, then you know this series is going to be convergent to divergent. You're going to use it to this series is going to be converged divergent. Okay, so you're going to practice for this series and you just check the solution in the note on the blackboard.